Welcome to this class on course circuit theory. In the last class we have discussed on the Maxwell's equation and we came to the conclusion that if I would like to analyze even the simple electrical system and if I'll use the field interpretation, then it may be difficult for me to analyze the system in a simple way. So what I should do, I should look some alternative, and circuit theory is an alternative or is an approximation to this Maxwell's equation. And from this class onwards we will analyze the electrical system using circuit theory perspective. Okay. So before starting with, let us discuss on first the properties, or what are the properties of the circuit theory, circuits or networks, or what are the classifications of the networks, and then we will just quickly see the basic terminologies which were involved in this particular course, and we'll end up with the KVL and KCL laws with one numerical example. Okay, so with this, let me start with the properties of circuits, or I will call it as networks. Okay, or I can also say that as the classification of circuits or networks, or the circuits or network which will be made up from the two terminal elements. Okay. So if the two terminal elements, if I am using in some of the network, that I can call it as a circuit or that network. Okay. So first property of the circuits is lumpedness, or with that property I will classify the circuit or network as lumped or distributed network. Let me write NW, or lump or distributed two terminal elements also. Second is based on the linearity property. So based on the linearity property, I can classify as a linear or a non-linear network or circuit. Then third, based on the the passivity, I can classify as the passive or active elements or active network, because it may made from the elements. Generally the network used to made from the elements. Then fourth will be the direction of the circuit, so direction of the network, where it is, how it is working, and that can be classified as unilateral or bilateral elements, or the elements it made from that elements made some network, so I can call it as unilateral or bilateral network. Fifth will be on the invariance, that is time invariance, so I can classify it as time invariant or time variant network. Then based on the causality also, I can define or I can classify the network, that is causal or non-causal network. Based on the finiteness, that is finite number of charges, so I can say that is finite or infinite network. We cannot imagine basically the infinite network. Most of the thing we are using are the finite network, but if you'll see in the ionosphere, it consists of the infinite number of charges. That's why we can make it as an infinite, or we can classify it as finite or infinite network. Again, also you can classify stable or unstable network also. Okay, so let us look these networks one by one. So first let us discuss on lumped network or distributed network. So let us define what is lumped and what is distributed. So lumped circuit or lumped system basically is a special case of Maxwell equation, and lumped network is that whose dimension will be very less than that of the wavelength of interest. Or in other way, if I am saying the wavelength of the excitation should be large than that of its dimension. Okay. So in this lumped network, the space variable is of no importance, whereas if the network which will depend on the space, then that kind of thing will be your distributed network. Okay. So in distributed network, space is very important, whereas in lump, space is not at all important, or space we are not considering as a variable, which is space. Okay. So distributed network, I can give the example, that is telephone lines. Power systems are nothing but the networks where the space is important. Okay. So the definition, you can say that the lumped network is that where the dimension of that network will be very less than that of the wavelength of interest. For example, if some network, assume that one network I have which is black blocks, which is 2 terminal only, and to that, if I am, this network is something is, if this some network is operating at a frequency of, let's say, 1 hertz. Okay. So, and also the network is operating at a frequency of 10 gigahertz. So these are the two conditions, and now I would like to find out what is the wavelength for first and second case. So first case, let me find out what is the wavelength, and we know how to find out the wavelength, which is the ratio of speed of light over the frequency of interest. So speed of light will be 3 into 10 raised to 8 meter per second, then frequency is in hertz, so it is almost 300 kilometer will be the wavelength. Whereas in this case, what will be the wavelength? Wavelength will be 3 into 10 raised to 8 divided by 10 gigahertz, so it will be 10 into 10 raised to 9, and it will come out as 0.03, so it will be 3 centimeter. Okay, so now you look these two situations carefully. That is the network which is operating at very low frequency, so I am getting the wavelength is very high, whereas if the network is operating at very high frequency, I am getting the low wavelength. Okay, so when the dimension, that is, if I am representing the dimension is d, if the dimension is very small than that the wavelength, then that kind of network called as circuit. Okay, and the function of circuit will be to transfer and transform the energy. So with this, based on the wavelength and the dimension, we can classify basically the network into 3 categories. One will be, I can say that when dimension is very less than that of the wavelength. The other category, I can say that when dimension is very equal to the wavelength, and other will say the dimension is very much greater than that of wavelength. Okay, so if I am saying this wire, a simple electrical wire that belongs to this, whose dimension is very small than that of the wavelength. So if the dimension is very small than that of this, then that kind of thing is called circuit, or it is your lump circuit or lump network. If dimension is approximately same to the wavelength, then that kind of system or network is used in microwave, or behavior is the microwave behavior. And if this dimension is much greater than that of lambda, then that behavior is a distributed behavior or distributed network or distributed system. And the example for this is the power system, and you can say the optics also. Okay, so if this is the case, then what is its implication? That is, if d, that is the dimension is very small than that of your lambda, that is our the, if the mouse also you can take, the dimension is very small. Okay, so that kind of thing is lumped. Okay, so what is its implication basically? So when d is very small than that of lambda. So in this course we are interested in this particular condition. So let us say what is its implication. So we know that lambda is equal to speed of light upon f. So from that, what I can conclude, if the wavelength is large, means speed of light is very high. It means speed of light is very high in circuits. It means propagation will happen instantaneously. It means there is no time lag in the network or in the circuit to happen something. Okay, so what does it mean? It means because why it is, because the speed of light is very large, means it tends to infinity. Okay, so if this is the case, then what will happen? There will not be charge accumulation. So if there is no charge accumulation, then charge will pass through that, and the circuit basically made of the wire, so charges will pass through the wires. So when you are dealing with such kind of the representation, then that element which you are using in circuit, they will have the two leads basically. So when you are using this low dimension the element, then it will have two leads like this. And in this when speed of light is infinite, what does it mean? When speed of light is infinite, so what does it mean? Suppose I have this element, and to this I am passing current I of t. So what will happen? Immediately at the output terminal, the same current, same amount of flow will happen here. Not same current, but current will appear at the output lead with way at the same amount of time. So when current pass through the element, then due to infinite speed of light, same current will be at the output leads. Okay, means that there is no propagation delay. Okay, it means that there is no charge accumulation. Okay, so current will come out at the same time, whereas this thing will not be true in case of your microwave or in case of your antenna. There will be definitely some propagation delay will happen. Okay, so that is why when we are taking like this as an input to some terminal, say this is my element, and to that if I am applying the input, immediately I will get the output at that across that terminal, if it is a voltage or a current also. Okay, so at the output immediately I can see the response. This is because wavelength is very high, means there is no charge accumulation, charges are passing. Okay, and this is what the reason is. At the same time we can observe the response at the output of output terminal of the network. Okay, this is one one type of circuit, that is called lump circuit or lump network. Then second is based on the linearity property, so I can also classify the network or the circuit is linear or non-linear. So basically, in order to say the circuit linear, your the circuit or network has to be relaxed. It means that initial voltage and current in the energy storage element should be zero. Anyhow, we'll define first what is the network, linear or non-linear. So the network will classify the linear or non-linear will be based on the voltage current relationship of the element. Okay, so in order to say that circuit is linear or non-linear, how to check it? The linearity can be checked again using two properties. One is your homogeneity property and second is your additive property, and if I'll combine both, it becomes your principle of superposition. So your network or the circuit said to be linear if it satisfies the principle of superposition, and in first year you would have studied the superposition theorem. So what it says that in superposition theorem, if we have more than one sources, and even though if I would like to find out the response, then how can we do it? We can find the response of circuit by suppressing the other sources and then find out the response, and at the end we'll add them up. I mean, we will superimpose all the responses which have obtained from various sources which were acting alone. Okay, so that is basically the superposition theorem, which is based on the principle of superposition. Now let us see what is homogeneity and additive. So homogeneity property, suppose I have the relation between input and output, say y of t is my output, and I have the relation between input and output as f of x of t. It means, suppose I have the network which is two-port network or two-terminal network. Okay, and to that, suppose I am giving the input as v1 of t okay, and I am getting the output as VO1, for example, VO1 of t. Okay, let us, you can consider current voltage or voltage current, whatever it is. So suppose I'll give I1 as an input to the terminal. I am getting output. I can consider response. Suppose the response I am considering as the voltage VO1t. Okay, then this current or this input I have multiplied by an amount, suppose K1, to this. Okay, so what will happen at the output side? It will be also the response which I got it for some I1 of t will be also multiplied with the same amount K1. Okay, this is your basically homogeneity property. Now when your K1 is 0, it means what? Your output response is 0. Okay, means VO1 of t will also be 0. It means that 0 input should get the 0 output for the linear case. Okay, so that is also one of the property. Based on the homogeneity we can declare 0 input, 0 output. Okay, so this is basically homogeneity. And now what about additive? Suppose one response, one excitation I have given as an I1 of t to the network, and response I got it as VO1 of t. Now second excitation I have given as I2 of t, and from it I got the response as VO2 of t. Okay, and now if I am getting added with both the excitations and apply to same network, that is I1 of t and I2 of t, if I'll add, so what will happen at the output? That the output which we have been obtained from I1 of t and I2 of t, if the network is linear, then that output or responses will also be added, VO1 of t and VO2 of t. So it means combinedly I can write it as the homogeneity and additive property. Okay, so means it will K1 I1 of t plus K2 I2 of t. So what will happen? It will give me VO1 of t plus VO2 of t. It means what? It will be also same, that is K1, which will be simply K1 VO1t and K2 VO2t. If VO1 is the response of I1t and VO2 is the response of I2t. Okay, so this way there will be the cause and effect. And now let me write mathematically in general. So there will be the operation or the relation has been specified by f, which we have already declared, that is y of t, that is the output, and this is what the relation I got it between output and input to the system. So in general I can write that the function or the operation on the two inputs, that is x1 of t and x2 of t, scaled with amount a1 and a2. If I am doing this, and if the system will be linear, then it should be equal to a1 operation on x1 of t, I can write as a function of t, plus a2 f on f is the operation you are doing or the relation between input with output, so f x2 of t. Okay, so let us take it with one example. For example, suppose I have the relation between output and input as p of t is equal to r I square of t. Okay, this relation we know, that is the power absorbed by r. Okay, so now suppose r is constant. Now let me define, let me check it out whether this system is linear or non-linear. So suppose p of t is my output y of t, and r and input I square of t is my x1 of t, so x1 of square of t. Okay, so let me write what is f here. F will be square. Okay, so let me write in this form, or I can use this also. So let us use what is f. F is square, so let us multiply with one constant, that is a1. What is input? R I1 plus a2 r I2, and what is the operation? Operation is square. Okay, now this, if it is a linear, then this should be equal to a1 operation is square on input, so it is r I1 of t square plus a2 operation on the second input, which is r I2 of t square. Is it equal? Let us solve this. So we will get it a1 square r square I1 square, A2 square, R square, I2 square plus 2A1, A2, R square, I1, I2, and on this side is what? A1 R square, I1 square plus A2 R square, I2 square. And if you see both the side, this is not at all satisfied. That's why this relation which we obtained between current with the power is not at all linear relation. Means what? The element which I have been obtained, or the relation which I have been obtained from the network, is not a linear kind of relation between power and current. Okay. Now, instead of that, if I take the relation for the circuit in terms of voltage and current, as already we decided that to check it out the linearity, I will just assume the relation between voltage and current. So suppose I will write for the same resistive element, so V of t will be equal to R I of t, and to identify whether linear circuit or network or not, so that I will try to obtain, or I will try to check with the help of voltage current relationship. Okay, so which is R into I of t. Suppose R is a constant. Okay, so how to check now? Suppose this is my input R I1 of t. So what is function? Function is nothing, it is simply the linear relation, okay, with the slope R. So obviously this is my linear relationship. Now again let me write the relation between voltage and current for the inductor. So V will be equal to L di by dt. So what is F here? F will be d dt. So now let us check it, the linearity here. So what's the function? Function is d dt, and let me write A1 if input is L I1 of t plus A2, next input is L I2 of t, and this should be equal to A1. F is what? d dt on input L I1 of t plus A2, function is d dt, and function means the relation which I got it, F as d dt and L I2 of t. So let us solve this. So if you solve, you can write as d dt of I1 of t plus A2 L d dt of I2 t, which is also same, you will get A1 L di1 t by dt plus A2 L di2 by dt. So you can say that both the sides are equal, and that's why inductor, that is two terminal network, satisfy the linearity property. Similarly also you can check it for the capacitive element also. So this will also be linear, because for capacitor also what we can have the relation 1 upon say integral I of t dt. So integral operator is also, you know, it will give me the linear operation. Okay, so all resistors, inductors and your capacitors will be the linear two-port network, two terminal elements. Okay. But if you consider the voltage source, that is the independent voltage source or ideal voltage source, ideal current source, then if I am writing what is the relation between the ideal voltage source, between voltage and current, it will be like this, and it is not at all linear. So independent or ideal voltage source and current source are non-linear elements, whereas RLC are my linear elements. Okay, that will also you can say, and the network which will made from RLC will be a linear network. Then third is property, or third property is your passive network or active network. So how to check that? So suppose I have a network, to that there are multiple ports, okay, and with the condition that with the multiple port, and that, you know, the outside terminals, the sources are connected with the assumption that there is no source present inside the network. Okay, all the sources are present out this terminals that is outside of the network. And then if this network will be passive, so what is the condition for passive? If you integrate from, let's say, minus infinity to t, and voltage across that terminal, across the element inside the network, and the current passing through it, if it is 0, or if it is greater than or equal to 0, or if it is non-negative, then that is your passive network or passive element. Okay. And if I'll add for all the elements which are present inside of the network. Okay. So let me write I is 1 to small n. Okay. So what it means, it will deliver the energy. Okay. So for example, consider the energy delivered to two terminal network from minus infinity to plus infinity. Let me write, this is basically energy only, so let me write in terms of t. So minus infinity to t, v of t, I of t dt, it has to be greater than or equal to 0. It should be always non-negative if the network is passive. Okay, for example, consider the linear resistors with constant, the value r. So here if I am taking e of t, so what will be across this, what is v of t, it will be r into I of t for dt. Okay, so if I solve, it will be minus infinity to t r I square of t dt, and if you look this, whatever the r has to be constant, you will always get whatever I of t, if you square it, you will always get the positive quantity. Okay, so this will be positive for any t. Okay, that's why resistor comes under the passive element. Even though if you take it the L, that is the inductor or capacitor also, let me write the same energy delivered for it. It will be minus infinity to t. What is v of t across L? It will be L di by dt into I of t, and if you solve, I'll get it half L I square of t. So again, L is positive, L has to be positive, and I square t will be always positive for any t. That's why L will also be passive element. Similarly, capacitor will also be passive element. But again, the question may come as L and C. Suppose I have this, and these are the energy storage element, but the question may come in our mind that it is also giving the energy. Okay, so it is to be noted that the values of L and C are positive. Okay, and these are my energy storage element. It can deliver the energy to other element only whatever the amount of energy has been received. So it can deliver, it can deliver energy only as much as energy which has been stored in that particular L and C. It cannot generate energy and it cannot deliver it. Okay, so thus inductor and capacitor cannot employ to deliver the energy to other elements for indefinite amount of time. Okay, or indefinitely, whereas independent voltage source and current sources will be delivering the energy for any duration. Okay, thus L and C can be categorized into passive elements, and the voltage source and current source can be categorized as active elements. Okay, and the network made from RLC, I can see that I can call it as a passive network. Then next is my direction. Based on it, I can categorize as the bilateral or unilateral element. So to decide, basically bilateral or unilateral element or the two-port element, it refers to two terminal elements only we are talking about. The element is said to be bilateral if it allows to flow the current in both the directions. Okay, for example, if I have the element like this, okay, to this, if I am connecting some source this way, and suppose these are my terminals, first positive and negative. If I am making this, so what will happen? Current is flowing in this direction. Now what I will do, I will change the direction of the source. It will be negative and positive. So what will happen? The same amount of current will flow in this. Okay, so if that element satisfy this property, then that element will be bilateral element. RLC will be bilateral element. Whereas if I am saying the diode, it will allow the current only in one direction, that is, it is unilateral. Whereas if I am saying the transistor, so transistor is not two terminal, basically it is a three terminal element. But if I'm taking the two terminals, then also can be decided whether it is bilateral or unilateral. Okay, so transistor is not two terminal network, that's why this is my ill-posed question, you can say. Okay, so this way we can decide unilateral or bilateral. The next comes time invariance or time variant network. So already that we have discussed in the first class itself, what is time invariant or what is time variant. Time invariant circuit or time invariant network is that whose elements or the values, what are the elements, RLC or the elements of circuits, parameters, those parameters of the circuit which are elements, these values, if they are not changing with respect to time, then these elements are called then the network which will be made up from these elements are called time invariant network. Okay. And if I am saying R is a function of time, L is a function of time, and C is also function of time, means R, L and C varies, then that kind of network will be time variant network. Okay. This is the case. Variable register comes under the time variant network. The next is the causal and non-causal. So basically this, let me put it in generalized form. If the present value of output is depending on the present value of input and past values of input, then that kind of thing is called causal circuit or causal system. Okay. What is it? Suppose, let me take it t as one instantaneous value. Suppose t is 3. Now present value of output is, I am calculating y at third second or at value 3. So what will happen in the input? Input is x of 3 plus x of 2, means what? Present value of output, that is if I am evaluating the output at third second, what it is depending on the third second as well as second also. So present value of output is depending on the present value of input as well as past value of input. Whereas if I am saying this present value of output is like this, so now here what will happen? Here it will be x of t is 3, so it will be 5, means what? Now where I am calculating the output I am calculating at third second, but for that I need the future value of input, okay, which will be at 5 seconds, that I doesn't know. It means if the present value of output is depending on the future value of input, then that kind of circuit or system or network called non-causal network. Okay. Stable and unstable is that stable or unstable system or network is which will behave according to me, that is my stable network, and which is not giving the response according to me, that is unstable network. Means if it satisfies the bounded input and bounded output property, then that kind of network is called stable network. For example, if I have a network, to this network if I am giving bounded input means which will have some lower value and the higher value which is limited, say 2. Okay. So output also should get it bounded, maybe lower limit and higher limit, like this 3. Okay. So it is having lower limit and higher limit, so that kind of network satisfy the stability. Whereas if I am applying this, but at the output I am getting this way, so this is not bounded output. I am applying the bounded input, but I am not getting the bounded output. This is infinite output, which is not bounded. Because why? Because this magnitude is not finite, it is infinite. That's why it is not satisfying the bounded input bounded output criteria. So in this situation, such kind of network is called unstable network. Okay. So these are basically the different properties of the circuits. So with this what we came to know, that the course which we will be going to study will satisfy all these properties. So, and this also satisfy this formula, that is LPF, LP, that only elements we are going to consider. That is the element which will satisfy the lumped, linearity, the element should be passive, the element should satisfy the finite property, and it should be bilateral. These only elements we are considering in our circuits. Okay. So with this, now let's continue with some terminologies. that is here what is node, mesh, then what is loop, what is series, parallel, then what is in short current, voltage, then we may have energy and power. Then we will see what is voltage source, same current source, what is KVL, KCL, etc. Okay, just have a brief discussion on it. So to see this, let me see one network like this. If I am drawing this network, okay, which are the elements? I am not taking the specific elements. Suppose these are the elements. Now in order to define the node, what is node? Basically the node is that when two or more leads will meet at a point, then that point is node. In circuit theory course, where I am repeating again, when two or more than two leads meet at a point, then that is my node. For example, let us see, and this concept came from the graph theory. So here this one lead, second lead, third lead, so it meets at one point, so that is my node. Here one lead, two lead, third lead, so all are meeting at one point, so this is node. Two leads are meeting, this is one node, this is also one node. Okay, so how many nodes are there? Let me write n for the node, which will be 5. Similarly, what is mesh and loop? So in order to define the loop basically any closed path which will made up from the branches. And what is branch? Branch is that which consists of some element. So this is one branch, second, third, fourth, fifth, sixth and seventh. Okay. So loop is the closed path made from the branches. So this I can call one loop, this is second loop, this is also third loop, etc. And what is mesh? Basically mesh is also the loop, but which doesn't have the inside loop in it. For example, if I am taking this loop, so there is no inner loop present, so this is called mesh. This is called mesh. Whereas if I am taking this as whole, then I am observing that there are inner loops also present, so this I cannot define as mesh. So basically mesh is a subset of loop. Okay, so suppose there are m number of meshes present in it. So if I would like to compute the branches, so what is the relation? Number of nodes plus number of meshes minus 1. With that also you can find out number of branches. So here nodes are 5, meshes are 3, minus 1, so it will be 7. So 7 number of branches means 7 number of elements will present here. 1, 2, 3, 4, 5, 6 and 7. Okay. Then what is series? Series is that when elements will share the node exclusively, then that is your series network, and if it is not, then that will be a parallel network. Okay, so this is what the series. Then what is current? Basically we know it is the rate of change of charges is defined as the current, and the symbol for that is suppose I. So I is defined as rate of change of charges per unit time, or it's the ratio of small charges per unit time, that is small time. Okay, and in general why I symbol we are using in this course? If I would like to represent the complex number, we are representing the complex number with the letter J. Okay, in 12th study you might have studied A plus IB, but in this course we will not represent the complex number with I, but will represent the complex number with J, because I is the symbol small I which will be used for the representation of your current quantity. Okay, this is my current. The next we know the voltage. So what is voltage? It is basically, suppose I have 2 points A and B, and I would like to move the charge from point A to point B. So voltage between A and B defined as the rate of change of work has been done for small charges. Okay, so work done for small charges to move the charge from location A to B is nothing but your potential difference or voltage between A and B, which I can write as dW by dQ. Okay, this is what voltage. Now let me define energy and power. So as we know, Now power in general is defined as the amount of work has been done per unit time, that is rate of work to do. Now let me define what is electrical power. So electrical power can be defined as the product of V of t into I of t or V into I, and that we can establish this relation. Let me take it, the electrical power as rate of change of work done per unit time, and this also I can write in intermediate level, which will be dw by dq and which will be dq by dt, and we know these quantities. This represent the voltage required to move charges from one to other place, as well as this is the amount of current is flowing through that, which is my P of t. Okay, so the product of voltage and current will be giving me the power. But in circuits, when power basically is positive, then that power will be absorbed, and when power will be delivered, then that quantity will be represented with negative sign. And in circuits, the conservation of energy will satisfy that sum of power delivered or absorbed will be equal to 0 across or for each element. Okay, and but in domestic purpose we are paying for energy, not for power, so we have to define what is energy. So if I integrate the power from t1 to t2 period, then that is nothing but my energy. Okay, and this will be computed in terms of joules. Okay, fine. So with this we stop here. We'll continue in the next class. Thank you very much.